times negative 5 plus 1 times 6 plus 9 times negative 1 bracket modulus equals to 1 over 2 times 0 equals to 0 unit square. Based on the answer in A, what can you say about points A, B, and C? Since area is 0, hence point A, negative 1, negative 5, B, 2, 1, and C, 6, 9 are collinear.
Points A, 5, minus 1, B, 3, 3, and C, minus 6, 8 are the verticals of a triangle. Find the values of P if the area of A, B, C is 16 units square. 1 over 2 modulus bracket 5 times 3 plus 3P plus minus 6 times minus 1 and bracket we minus bracket minus 1 times 3 plus 3 times minus 6 plus 5p bracket and modulus is 16 units square. And 15 6 is 21 plus 3p and we bracket it minus bracket minus 21 plus 5p bracket modulus is 32 units square. Because 16 times 2, we throw the 1 over 2 to 16. So it is 42 minus 2p modulus is 32 units square. And I use it to divide 2, so it's 21 minus p equals positive and negative 16. So 21 minus p is 16 and p equals to 5. For the negative 16 is 21 minus p equals to minus 16, so p is 37. Thus, values of p are 5 and 37.
Very good. You can solve the modulus. Okay, very good. This one is not easy, but you can do very fast. Okay, very good. Another one, another presenter.
Length FG is equal to square root bracket x squared minus x2 minus x1 square plus bracket y2 minus y1 square. So it's equal to square root bracket 7 minus 4 square plus bracket 8 minus 4 square is equal to 5 units. Length FE is equal to length FG. So square root bracket 0 minus 4 square plus bracket k minus 4 square is equal to 5. We need to bring the square over, so it is become 5 square is equal to bracket 0 minus 4 square plus bracket k minus 4 square. 16 plus k square minus 8k plus 16 is equal to 25. K square minus 8k plus 7 equal to 0. Bracket k minus 7 bracket k minus 1 is equal to 0. K is equal to 7.
Why you reject the other answer?
Because the graph is drawn on the higher position.
Yeah, very good. You can answer me. It's logically based on the diagram. The k should be more than 4. So she rejected k equal to 1. Okay, good. Then, next.
And the B1 answer, length EH equals to GH
square root bracket 0 minus x bracket square plus bracket 7 minus 11 bracket square equals to square root bracket 7 minus x bracket square plus bracket 8 minus 11 bracket square. So I take out the square root, so it's bracket negative x bracket square plus bracket negative 4 bracket square equals to bracket 7 minus x bracket square plus bracket minus 3 bracket square. And x squared plus 16 equals to 49 minus 14x plus x squared plus 9. 0 equals to minus 14x plus 42. So the x equals to 42 over 14 and the x is equals to 3. So the coordinate of h is 3, 11. And
good.
And the B2 is a ratio of the area of EFG and EFGH. The area of EFG equals to 1 over 2 modulus 07447807 and modulus. So the area of EFG equals to 1 over 2 modulus bracket 0 bracket 4 plus 4 bracket 8 plus 7 bracket 7 bracket equals to bracket 7 bracket 4 plus 4 bracket 7 plus 8 bracket 0 bracket modulus equals to 1 over 2 modulus 25 close modulus equals to 25 over 5 unit square.
Okay.
And area EFGH equals to 1 over 2 modulus 07447831107 modulus equals to 1 over 2 modulus bracket 04 plus 48 plus 711 plus 37 bracket minus bracket 74 plus 47 plus 83 plus 11 0 bracket modulus equals to 1 over 2 modulus 50 modulus equals to 25 unit square. EFG over EFGH equals to bracket 25 over 2 bracket over 25 equals to 1 over 2. And so the ratio of EFG and EFGH was is 1 2.
Okay. Wow, this one is not easy. You are good. You can do so fast. Okay. There is a cooperation among you so that the things
which is -4, -3, and then 5, 1, and 2, 6. So I find the area is equal to 1 over 2 modulus -4, -3, 5, 1, 2, 6, -4, -3 close modulus, then equal to 1 over 2 modulus bracket -4 times 1 plus 5 times 6 plus 2 times -3 close bracket minus bracket -3 times 5 plus 1 times 2 plus 6 times -4 close bracket close modulus equal to 1 over 2 modulus 20 minus -37 then equal to 57 over 2. So the answer is 28.5 units square.
A, B, and C are collinear, so 0 equals to 1 over 2 modulus 8a -1, 2, 3, 10, 8a. 0 equals to modulus 8 times 2 plus -1 times 10 plus 3a minus a times
-1 plus 2 times 3 plus 10 times 8. So we simplify it and it will be 3a plus 6 minus -a plus 86 modulus. And then 0 equals to modulus 4a minus 80. A equals to 80 over 4. 24 equals to modulus 4a minus 80. 4a minus 80 equals to 24. A equals to 24 plus 80 over 4. A equals to 26, or 4a minus 80 equals to -24. A equals to -24 plus 80 minus 4. A equals to 14.
You are by 4, huh? Okay. All right. So, okay.
The coordinates of 3 LRT stations, Payaredan, Kampong Raja, dan Banjang Sari are represented by points A 09, B 70, and C 1212, such that one unit represents 100 meter. Find the distance in km between Payaredan station and Kampong Raja station. The distance between Payaredan station and Kampong Raja station equals to distance A and B. Distance is equal to square root x2 minus x1 square plus y2 minus y1 square, and it is equal to square root 7 minus 0 square plus 0 minus 9 square equals to square root 130, equal to 11.402 units. The question states that one unit represents 100 meter. So here 11.402 units times 100 meter equals to 1140.2 meter, and it is equal to 1.1402 km. B. The actual area in km square of the triangle formed by the 3 stations. Area equal to 1/2 modulus x1 y1 x2 y2 x3 y3 x1 y1 closed modulus. It is equal to 1/2 09 70 12 12 09 equal to 1/2 0 plus 7 times 12 plus 12 times 9 minus 9 times 7 equal to 1/2 modulus 84 plus 108 minus 63 equals to 1/2 times 1 times 129 equals to 24.5 units square. 1 unit is equal to 100 meter and it is equal to 0.1 km. So 1 unit square is equal to 0.01 km square. 64.5 unit square is equal to 0.645 km square. So the area covered by the 3 stations is 0.645 km square.
Given, and the vortices given are 3, 1, 6, 4, and -4, 2. So first I did was I write A equals to 1/2 and then the modulus, and then I would list them according to x1, y1, x2, y2, x3, y3, and then I repeat the first vortice, which is x1, y1, and then I close the modulus. Then I have A equals to 1/2 modulus 3 times 4 plus 6 times 2 plus -4 times 1 minus the bracket 1 times 6 plus 4 times -4 plus 2 times 3, and then I close the bracket and then close modulus. I did this because I'm supposed to cross multiply first in the first section, and then I would just minus and then I do it in the other direction. Then I sum up it and then I get 1 equals to A equals to 1/2 times the modulus 20 minus 4. So A equals to 1/2. Oh, sorry, teacher, this is updated. 1/2 modulus 24. So I have A equal to 12 units.
24 or 12?
Units.
Units.
Yeah, I updated, but I don't think it's updated there.
Oh, okay. That means there's a -4 behind lah, is it?
Yeah.
Okay. So the answer is 12 lah.
Yes.
Alright. Okay, good. Looks like no problem. You can explain to me why the answer is not the same like in the slide lah. That's good.
For A, B and C are collinear, so 0 equals to 1 over 2 modulus 8a negative 1, 2, 3, 10, 8a. 0 equals to modulus 8 times 2 plus negative 1 times 10 plus 3a minus a times negative 1 plus 2 times 3 plus 10 times 8. So we simplify it and it will be 3a plus 6 minus negative a plus 86 modulus. And then 0 equals to modulus 4a minus 80. A equals to 80 over 4. A equals to 20.
Yeah, very good. Okay, that is how you solve the modulus. B?
Okay, for B, the area of ABC is 12 units square. So 12 equals to 1 over 2 modulus 8a negative 1, 2, 3, 10, 8a. 24 equals to modulus 4a minus 80. 4a minus 80 equals to 24. A equals to 24 plus 80 over 4. A equals to 26, or 4a minus 80 equals to negative 24. A equals to negative 24 plus 80 minus 4. A equals to 14.
So I find the area is equal to 1 over 2 modulus -4, -3, 5, 1, 2, 6, -4, -3, close modulus, then equal to 1 over 2 modulus bracket -4 times 1 plus 5 times 6 plus 2 times -3, close bracket, minus bracket -3 times 5 plus 1 times 2 plus 6 times -4, close bracket, close modulus, equal to 1 over 2 modulus 20 minus -37, then equal to 57 over 2. So the answer is 28.5 units squared.